Welcome to science, to sleep by. Tonight, we drift beyond the stars, into a universe that isn't flat or still but gently curved, like the folds of a quiet dream. Space itself bends and sways around every star, every planet, even around you. So close your eyes, slow your thoughts, and let your mind follow the graceful curves of the cosmos, as we explore one of the most beautiful truths of all: why space bends. Imagine yourself floating in space, surrounded by an infinite sea of darkness. There are no sounds, no winds, no boundaries. The stars glimmer like distant embers, suspended in silence, and the earth spins far below, in a blue haze of light and life. From here, everything appears still. The universe looks frozen in a quiet, eternal calm, a perfect stillness that seems untouched by motion or change. But this calm is only an illusion, a fragile reflection of something deeper and more intricate. Space, though it appears empty and peaceful, is alive with an invisible rhythm. It bends, it stretches, it curves and flows like a slow cosmic tide. What seems still to our eyes is actually a vast ocean of motion, shaped by every planet, every star, every particle of energy that ever existed. When we gaze at the night sky, we often imagine space as a flat backdrop, a silent, endless stage where galaxies drift and stars burn. But in truth, space is not flat and it is not empty. It has structure, texture, and depth. The emptiness we think we see is filled with the invisible geometry of reality itself. If we could look closely enough, past the starlight and the distance, we would see that the space between everything is not nothing at all, but something that can bend, twist, and ripple. The stillness of the cosmos hides a subtle dance, one that has been unfolding since the dawn of time. Centuries ago, people imagined space as a static void and endless nothingness in which planets and stars floated like marbles in glass. Even great minds like Isaac Newton described space as an unmoving stage, eternal and unchangeable, while gravity was thought to be an invisible force pulling objects toward one another. It made sense at the time, and it worked beautifully to explain the motions of the planets. But this view was only a surface reflection of a deeper truth waiting to be discovered. The calmness of space, as we perceived it, was never truly still. Beneath the stillness was a fabric capable of bending under the weight of mass and energy. In this vast stillness, every object from a tiny pebble to the mightiest black hole leaves a mark. Each one presses into the fabric of space, shaping it, curving it, influencing the paths of everything nearby. The Earth, for example, doesn't orbit the sun because it's being pulled by some unseen string. It moves because the sun's mass bends the space around it, creating a gentle well that the Earth naturally rolls along. Like a marble gliding along the curve of a stretched sheet, our planet follows the graceful contours of space's geometry, endlessly circling the sun in a cosmic waltz. If you could see space itself, not the stars or the galaxies, but the invisible structure that holds them, it would not look still at all. It would look like an endless, transparent ocean, rippling and folding around every form of matter. When a planet moves, it stirs tiny waves in the fabric. When a massive star collapses, it sends out ripples that travel across billions of light years, whispering of the event long after it has passed. Even here around you, space is bending. The ground beneath your feet, the air around your body, even the room you sit in, all are part of a spacetime that curves gently under the weight of the Earth's mass. To the human eye, this bending is invisible, but it governs everything we experience. The fall of an apple, the orbit of the moon, the steady ticking of time itself, all are shaped by the quiet geometry of the universe. The stillness you sense when you look up at the night sky is not absence, it is harmony. Space does not shout its movements. It hums softly in the background of everything. The stars seem frozen because their light takes so long to reach us, but in reality, each one is moving, pulling and bending the space around it as it travels. This bending is gentle and constant. It does not begin or end. It simply is. The universe is a living fabric, a continuum that connects all things. What we perceive as stillness is actually a perfect balance between motion and form, an equilibrium. maintained by gravity's soft pull and space's graceful flexibility. You might imagine the universe as a great blanket spread wide, and every star and planet as a weight upon it. The fabric dips and curves under those weights, creating valleys and slopes that other objects slide along. That is what space bending truly means, not a force pulling from afar, but a structure reshaping itself around what exists within it. This realization changed everything about how we see the cosmos. It revealed that the universe is not just a place, but a dynamic being, capable of responding to the presence of matter and energy. Even the passage of time is part of this living structure. Where space bends, time slows. Where gravity is strong, moments stretch. This means that in places of extreme curvature, near black holes, for instance, time itself can nearly stop compared to the flow of time elsewhere. The stillness of the cosmos is therefore not just a stillness of motion, but a stillness of time, one that flows differently depending on where you are within the folds of the universe. Close your eyes and imagine floating in that silence again. Around you, the stars are not just points of light, but great distortions in spacetime, shaping invisible wells that curve away from their centers. The Milky Way itself is like a vast spiral carved into the geometry of the cosmos, bending the surrounding fabric as it spins. Every planet, every moon, every grain of cosmic dust contributes to this shape, tugging gently on the threads of the universe. You are part of that same web. Your body, your planet, even your breath, adding the tiniest ripple to the infinite stillness around you. And though you cannot see it, you are constantly moving along these curves. The Earth carries you around the sun carries you around the galaxy, and the galaxy drifts through the expanding universe, all of it guided by the curvature of space. Each motion is an expression of geometry, each orbit a quiet testimony to the flexibility of the cosmos. The stillness we sense when looking up is not the stillness of rest, but the stillness of perfect balance. A balance so vast and harmonious that it feels like peace. If you could listen to the universe, you would not hear silence, but the low, steady hum of curvature. Every bend in space is like a note in a grand cosmic symphony, vibrating slowly across eternity. The rhythm is so slow that it escapes our perception, yet it surrounds us always. Even light, traveling through space at unimaginable speed, follows those curves, weaving through the invisible valleys of spacetime, its path determined by the gentle bending that gives structure to everything. The stillness of the cosmos is the stillness of a sleeping giant, not lifeless, but profoundly alive, dreaming in curves and waves. It is the stillness of a system too vast for motion to seem real, too balanced for chaos to be visible. What we see as emptiness is a web of connection. What we feel as silence is the gentle breath of gravity shaping the stars. And what we call stillness is only the illusion that our limited senses can perceive in the boundless geometry of the universe. At the dawn of the 20th century, humanity stood at the edge of a scientific awakening. For centuries, we had believed that space and time were separate, that they formed the unchanging stage on which the drama of the universe unfolded. Gravity, we thought, was a force invisible but ever-present that tugged on every object, pulling apples to the ground and planets around the sun. Isaac Newton's laws had described this beautifully for more than 200 years. They explained orbits, tides, and falling objects with the precision that shaped the modern world. Yet, deep within that mathematical perfection, a quiet question lingered. What is gravity really? Why does it pull and through? What does it act? Einstein's revolutionary dream began with that question. Albert Einstein was not the kind of scientist who accepted the world as it appeared. He believed that truth lay beneath the surface, hidden within the ordinary. He had a restless curiosity, a mind that would not sleep until the universe made sense. In the early 1900s, while working as a patent clerk in Bern, Switzerland, he would spend his evenings imagining himself chasing beams of light. He wondered what the world would look like if he could ride alongside a ray of sunlight, moving at its speed. What would happen to space, to time, to light itself? This simple but profound question became the seed of a revolution that would change our understanding of reality. In 1905, Einstein published his special theory of relativity. showing that time and space are intertwined, that they are not separate entities, but two aspects of the same fabric. This theory revealed that the faster an object moves, the slower time passes for it, and the more its length contracts. Space and time were no longer absolute. They were relative to the observer's motion. But special relativity only described the world when gravity was absent. A flat spacetime, without curvature, without the pull of massive bodies. The next step, Einstein realized, was to bring gravity into this picture, to understand how it fit within this new framework. For nearly 10 years, he struggled with that question. It haunted him as he searched for a deeper truth, a law that would replace Newton's view of gravity as a force with something more elegant, something more fundamental. He began to imagine space not as a stage, but as a flexible fabric. He envisioned that mass and energy could tell this fabric how to curve, and that this curvature could, in turn, tell matter how to move. In 1915, after years of intense thought and mathematical exploration, Einstein presented his general theory of relativity to the Prussian Academy of Sciences. The world changed in that moment. Einstein proposed that what we feel as gravity is not a force pulling on us through space. It is the shape of space itself. Massive objects, like stars or planets, cause the spacetime around them to bend. Other objects, moving through that region, simply follow the natural curves of this geometry. There is no mysterious tugging or pulling. The apple falls from the tree not because the earth pulls it down, but because the earth has curved the spacetime around it, and the apple is moving along that curved path, the straightest possible path in a curved world. To the apple, there is no force at all, only motion through a bent geometry. This idea was radical, yet beautifully simple. Einstein turned gravity from a force into a feature of the universe's structure. He unified space and time into a single concept, spacetime, and gave it flexibility, the ability to bend, stretch, and twist under the influence of matter and energy. The implications were profound. Suddenly, the cosmos was no longer static. It could stretch and expand. It could ripple. It could change its shape. Space was not empty. It was alive. At first, few could truly grasp the magnitude of what Einstein had done. The mathematics of general relativity was complex, and the idea of curved space seemed almost mystical. But then came proof. In 1919, during a total solar eclipse, British astronomer Sir Arthur Eddington led an expedition to test Einstein's predictions. According to general relativity, light from distant stars passing near the sun should be bent by the sun's curved spacetime. During the eclipse, when the sun's light was blocked, Eddington photographed the stars near the sun's edge. When the images were developed, the starlight appeared shifted from its normal position, exactly as Einstein's theory predicted. Space had indeed bent light. Overnight, Einstein became a global icon, the man who had redefined the universe. But for Einstein, the fame was only a shadow of what truly mattered. His discovery wasn't about prestige. It was about understanding. He had revealed that the universe is not made of separate, rigid parts, but of an interwoven whole. Space, time, energy, and matter are all part of the same cosmic tapestry. Every motion, every moment, every beam of light is shaped by the curvature of spacetime. To Einstein, this was not only science, but beauty, a harmony of mathematics and nature, a revelation of how deeply geometry and existence are entwined. This new vision of the cosmos opened doors to realms never before imagined. It predicted black holes, places where spacetime bends so steeply that not even light can escape. It predicted that the universe itself is expanding, a truth confirmed years later by astronomer Edwin Hubble. And it implied that time itself could flow differently in different places, a reality now measured with astonishing precision in everything from GPS satellites to atomic clocks. Einstein's revolutionary dream transformed our everyday understanding of time and space into something fluid and alive. Imagine standing on the surface of the Earth, feeling the gentle pull of gravity. According to Einstein, you are not being pulled at all. You are standing still in spacetime, while the fabric beneath you curves downward toward the Earth's center. The ground is pushing up against your feet to keep you from following that curve. When astronauts orbit the Earth, they are not defying Gravity, they are simply moving along the natural curves of spacetime, falling freely but never reaching the ground. Every planet, every star, every galaxy follows the same invisible choreography, moving through a universe sculpted by its own contents. Einstein's dream reshaped not just physics, but philosophy. It blurred the boundary between what we think of as space and what we think of as time, revealing that they are inseparable. Every second that passes on your watch is connected to every inch of space you move through. If you travel near the speed of light, time slows for you compared to those left behind. If you stand near a massive planet, time runs slightly slower for you than for someone far away. Time itself bends with space. The universe, therefore, is not a rigid grid ticking forward in mechanical rhythm. It is a flexible, breathing entity, constantly molded by the energy within it. For Einstein, this vision was not merely scientific, it was poetic. He often said that the most beautiful thing we can experience is the mysterious, and his theory of relativity was his way of capturing that mystery in the language of mathematics. He imagined the cosmos as a grand symphony, in which mass and energy played the instruments, and spacetime was the resonant medium that carried their song. He once wrote that his greatest joy was in discovering that the universe is comprehensible, that its laws, though intricate and abstract, follow a profound and consistent harmony. In the centuries since, every test of Einstein's theory has confirmed its truth. Light bends near massive bodies. Time slows in stronger gravitational fields, and gravitational waves ripple through space as predicted. His dream has become the foundation of modern cosmology, guiding our understanding of black holes, the Big Bang, and the very shape of the universe itself. Yet, even today, there is something deeply human about his vision. It began not in a laboratory, but in imagination, in the simple act of wondering what it would be like to chase a beam of light across the sky. That act of wonder remains at the heart of Einstein's legacy. His dream reminds us that science is not just about equations, but about curiosity, about daring to see the world differently. Space bends, time flows, and the universe evolves, not because we demand it, but because it is in its nature to do so. Einstein's vision gave us a universe where gravity is geometry, where motion is meaning, and where reality itself is shaped by the quiet conversation between matter and spacetime. It showed us that what appears solid and still is, in truth, endlessly curved, a graceful continuum connecting every atom, every star, and every thought within the boundless fabric of existence. Imagine the universe not as a vast emptiness, but as a smooth, invisible fabric stretched across all existence. It is not made of threads or particles, but of geometry itself, a four-dimensional expanse that fuses space and time into a single continuous entity known as spacetime. This fabric is the foundation of reality, the medium through which everything moves, everything happens, and everything exists. Every planet, every star, every beam of light travels across it, following the curves and folds shaped by the presence of mass and energy. It is everywhere, filling every corner of the cosmos, even the spaces we think of as empty. The universe is not built upon spacetime. It is spacetime. To begin understanding this concept, imagine a perfectly smooth sheet stretched tight. On this sheet, you place a small marble. The marble barely disturbs the surface, only a faint dent around it. Now, place something heavy like a bowling ball. The sheet dips, curving downward under the weight. If you were to roll another marble near the edge of this curve, it would spiral inward, not because it was pulled by an invisible string, but because the shape of the sheet directs its path. This simple image, though two-dimensional, is a glimpse into how the three-dimensional space we live in bends and curves within four-dimensional spacetime. Spacetime is not an abstract idea, but a real, measurable structure. It tells matter how to move, and matter tells spacetime how to curve. This is the essence of Einstein's general relativity, the great revelation that the cosmos is not governed by mysterious forces acting from afar, but by the geometry of the universe itself. Everything that has mass or energy presses into this fabric, and the fabric responds by bending. The greater the mass, the deeper and wider the curvature. The sun, for example, creates a vast well in spacetime, and the Earth moves along the curved walls of that well. To us, that motion looks like orbiting, but to the universe, it is simply the Earth following the natural path carved by the geometry around the Sun. What is most extraordinary is that this curvature affects not only the motion of objects, but also the passage of time. Where spacetime curves more strongly, time itself flows more slowly. Near massive objects like planets or stars, clocks tick just a little slower than they do farther away. This is not a matter of mechanical difference, but of reality itself stretching and flexing. Time and space are woven together so intimately that a change in one affects the other. When you move faster, time slows down for you. When you are closer to a massive body, space compresses and time dilates. The very concept of now is not universal, but depends on where you are and how you move through spacetime. The fabric of reality has no edges, no center, and no preferred direction. It extends infinitely, wrapping around itself in ways that defy our everyday perception. To the human mind, which evolved to see in 3 dimensions, this curvature is invisible. We walk across it, live within it, and move along its contours without realizing it's there. Every step you take, every orbit the moon completes, every pulse of light that travels from a distant galaxy, all of it unfolds within the same geometric ocean. Spacetime is not a background, but the main stage, and everything that exists is a pattern of ripples upon its surface. This fabric is incredibly sensitive to energy. Even something as intangible as light can bend space, though the effect is minuscule. A star's gravity can bend the path of a passing beam of light, causing it to curve around the star's edge. When light from distant galaxies passes near massive clusters of matter, the entire image can warp and stretch, creating arcs and rings of light in the sky. This phenomenon, known as gravitational lensing, is one of the most beautiful demonstrations of the fabric of reality at work. It shows us that space is not empty, but elastic, capable of bending under the weight of energy, capable of shaping the journey of light itself. Scientists have even measured this curvature directly. Satellites orbiting Earth use precise instruments to track how spacetime bends around our planet. The results match Einstein's predictions perfectly. GPS systems, which guide planes and cars and smartphones every day, must account for both the bending of space and the slowing of time caused by Earth's mass. Without adjusting for these relativistic effects, GPS calculations would drift by miles each day. What feels to us like a practical technology is, in truth, an elegant conversation with the geometry of the universe. The satellites orbit high above, moving through slightly different curvatures of spacetime, and every signal they send is a whisper across the cosmic fabric, perfectly tuned to the universe's curves. The fabric of reality is also dynamic. It is not frozen or fixed. It stretches and changes with time. When massive bodies move, they send out ripples, gravitational waves that travel across the universe like the rings spreading outward on the surface of water. These waves are unimaginably faint, yet they carry the signature of the most violent events in the cosmos: colliding black holes, exploding stars, merging neutron stars. In 2015, scientists detected these ripples for the first time with the LIGO observatory, confirming Einstein's century-old prediction. For the first time, humanity heard the sound of spacetime moving. The faint, rising tone captured by the detectors was not light or sound as we know it, but the vibration of the fabric of existence itself. Every part of the universe participates in this cosmic geometry. From the smallest atom to the largest galaxy cluster, everything contributes to the bending and shaping of spacetime. Even the vast voids between galaxies are not truly empty. They contain traces of energy, and that energy leaves an imprint on the structure of space. The entire cosmos is a seamless whole, connected by the continuous stretching and bending of spacetime. It is like a great woven tapestry, where every thread affects every other, and no single part can move without influencing the rest. To grasp the beauty of this fabric, imagine again the night sky. The stars you see are not scattered randomly in an empty void. They are embedded within the folds of a vast, invisible geometry. Their light travels along the contours of that geometry, bending slightly as it passes near other masses. The galaxies beyond our own lie on the same cosmic surface, bound together by the curvature of space. Even the expansion of the universe, the stretching of the fabric itself, is a feature of this reality. It means that spacetime is not static, but expanding like an inflating balloon, carrying galaxies with it as it stretches. The further away a galaxy is, the faster it appears to recede. Not because it is moving through space, but because space itself is expanding between us and it. This perspective changes the way we think about existence. It means that everything, every motion, every moment is a manifestation of geometry. When a planet orbits a star, when light bends around a black hole, when time slows near a massive object, it is not the result of a force acting across distance, but of the universe's fabric guiding the flow of motion. It means that you are never truly still when you sit motionless. You are always moving through spacetime, following its curves, carried by its shape. At the deepest level, this fabric of reality is governed by elegant equations that describe how mass and energy determine curvature. These equations are not arbitrary, but beautifully symmetrical, expressing the harmony between matter and the geometry that contains it. This realization has transformed not only physics, but our very conception of existence. It has shown that the universe is self-contained and self-determining, that its structure and its behavior arise naturally from its own geometry. Yet, even with all our understanding, there is still mystery. What is this fabric made of? Is it continuous, or does it have a deeper quantum structure, woven from tiny threads of energy or information? Theories like quantum gravity and string theory attempt to answer this, suggesting that spacetime might emerge from something even more fundamental, a hidden order beneath geometry itself. But for now, what we know is already extraordinary. The universe, from the smallest particle to the grandest galaxy, is united in a single, continuous fabric, curved and alive, shaping and shaped by everything it holds. In this vast and elegant structure, space and time are not mere coordinates, but living dimensions. They curve around stars, stretch across the cosmos, and ripple with the echoes of creation. The stillness of the night sky hides the subtle flexing of this geometry, the quiet dance of spacetime itself. The fabric of reality holds us, carries us, and connects us to everything that has ever existed, forming the invisible foundation of the universe's eternal flow. When we think of gravity, we often imagine it as a mysterious force, an invisible pull that keeps our feet on the ground and binds the planets to their orbits. For centuries, that idea was enough, a comforting simplicity that described how the universe worked. But beneath that simplicity lies a deeper and far more elegant truth. Gravity is not a pull at all. It is not a force that reaches out across space to drag objects toward one another. It is the shape of space itself, the curvature of the very fabric of the cosmos. It is geometry in motion, the universe expressing its harmony through form. Gravity is the silent music of spacetime, a symphony of curves that orchestrates everything from the fall of an apple to the dance of galaxies. Imagine the universe as a vast, invisible ocean. Every star, every planet, every atom creates a ripple in that ocean, bending and shaping it. When you move through this curved expanse, you are not being pulled by gravity. You are simply following the natural lines of the geometry beneath you. The Earth's orbit around the Sun is not a path forced by a distant hand, but a graceful movement along the contours carved by the Sun's mass. The Earth rolls along the Sun's spacetime valley like a marble on a curved surface, not because it is compelled to, but because that is the straightest possible path within the curve. In this way, gravity is not something separate from space. It is space, bending and flowing around the presence of matter. To grasp this, picture a great, flexible sheet stretched across the cosmos. Place a heavy sphere upon it. The sheet dips, forming a curve. Now, roll a smaller sphere across the surface. As it passes near the depression, its path bends inward. The smaller sphere does not feel a force pulling it down. It merely follows the shape of the surface. This is the essence of gravity, the tendency of all things to follow the geometry of spacetime. What we perceive as falling or orbiting is simply motion guided by the curvature around us. But the true beauty of this idea lies not in its imagery, but in its precision. Einstein's equations of general relativity describe exactly how this curvature arises. As we come to the quiet end of this journey, we return to the question that began it all. Why does space bend? We've drifted through the silent stillness of the cosmos, felt the pull of gravity shaping stars and planets, and traced the invisible curves that guide light and time themselves. What we've found is that space bends because it is alive with presence. It bends because matter exists. It bends because energy breathes through every atom, every photon, every thought that crosses the human mind. The universe is not an empty stage, but a living fabric that flexes and flows with the weight of everything it contains. Einstein's revelation showed us that gravity is not a force acting at a distance, but the shape of spacetime responding to mass and energy. Every planet, every star, even your own body, curves the space around it, however faintly. You are part of that same geometry, woven into the same fabric as galaxies, connected by the same invisible lines that guide the stars. The universe does not separate you from itself. It holds you within its curves, cradled in a vast, continuous whole. The bending of space is not just a scientific truth, it's a poetic one. It tells us that reality is not rigid, but fluid, that everything influences everything else, and that the presence of one thing changes the nature of all others. The path of light bends around stars, the flow of time slows in deep gravity, and the shape of the universe is sculpted by what it contains. In this way, space is not simply a background, but a living participant in the story of existence. When you look up at the night sky and see the stars shimmering from billions of light years away, you are seeing the result of this bending. Every beam of light that reaches your eyes is curved and stretched, passing through valleys of spacetime carved by massive worlds and invisible forces. Every flicker, every glimmer is a message from the geometry of the cosmos, a whisper of how deeply connected everything truly is. Even the largest patterns, the cosmic web itself, arise from this same principle. The grand filaments that link galaxies across the universe are extensions of spacetime's flexibility, the natural outcome of mass gathering and gravity shaping the void. From the smallest subatomic particles to the largest clusters of galaxies, all things are participants in the same universal curvature. The bending of space is the rhythm of existence itself, the heartbeat of the cosmos, made visible through light and time. Perhaps that is the most humbling truth of all, that the universe bends not just because of what is massive or grand, but because of what simply is. Every form, every thought, every motion leaves its subtle imprint on the cosmic fabric. You, too, exist as part of that curvature. You bend the universe around you, and in turn, the universe bends you. So when you close your eyes tonight and let the stars fade softly from sight, remember this: the stillness you feel is not emptiness, but harmony. The silence of space is not void, but balance. Space bends because everything in existence, seen and unseen, participates in its shape. It bends because the universe is listening, responding, and alive. And somewhere within that quiet curvature of spacetime, you are part of the story, a small, luminous ripple in the grand, bending fabric of forever.